Obtain lens maker's formula. Obtain lens maker's formula. Consider a lens having radius of curvature R1, R2, refractive index mu, thickness T to be situated in air. Write this much. Consider a lens having radius of curvature R1, R2 having refractive index mu, thickness T to be situated in air. Next line. Let O be the point object. Let O be the point.
Sir, I have to copy.
Huh?
I am copying.
You are copying first line also you have not done. What you are doing? Completed copying?
Yes, sir.
Let O be the point object at a distance U from first surface. O be the point object at distance U from first surface. To get its image, we have to draw two rays. First, ray OP incident normally emerges out without any deviation or lateral displacement. Second, ray OA incident on first surface, ray OA incident on first surface undergoes refraction and follows path AB. Undergoes refraction and follows path AB. Okay, written till this.
Yes, sir.
Produce AB and PO. Produce AB and PO backwards. Produce AB and PO backwards to meet at point I dash. To meet at point I dash. I dash is virtual image of object O. Let it be at distance V dash from first surface. Completed? Hello, completed till this?
Done, sir.
Done, sir.
Next line, I dash behaves as object for second surface. I dash behaves as object for second surface. Draw I dash B. It undergoes refraction and follows path and follows path BI. Let I be the final image at distance B from second surface.
Done, sir.
Case consider first surface. For first surface, object U is at distance U. V is V dash. Mu1 is air where object is placed. Mu2 is mu because ray after refraction becomes AB. And radius of curvature R is R1 for first surface. For single spherical surface, mu2 minus mu1 upon R is mu2 upon V minus mu1 upon U. This we have proved with proper convention. So mu2 is mu, mu2 is mu, mu1 is 1 because it is air, minus 1 upon R1 is mu2 mu, V is V dash, mu1 is air 1, object distance U. So for first surface, object is at U, image is at V dash, object is in air, so 1, image is after refraction AB, that is mu, R is R1. For a single surface, we have already proved in the last lecture, mu2 minus mu1 upon R is mu2 upon V minus mu1 upon U. So therefore mu minus 1 upon R1 is mu2 mu V dash 1 U, equation. Copy till this.
Done, sir.
Consider second surface. For first surface, we got one relation, second surface will get relation, join them, it will become length. So for second surface, object is V dash, image is V, mu1 is mu, and mu2 is air, so 1, and R is R2. Now for single spherical surface, mu2 minus mu1 upon R is mu2 upon V minus mu1 upon U. 1 minus mu upon R2 equals to mu2, which is 1 upon V minus mu1 is mu upon V dash, equation 2. Copy second surface wala formula. Then we'll just add, we'll get required answer of lens maker's formula. Completed?
Done, sir.
Adding 1 and 2, we get mu minus 1 upon R1 plus 1 minus mu upon R2 equals to mu upon V dash minus 1 upon U plus what you got second term right hand side
1 upon V minus mu upon V dash.
1 upon V minus mu upon V dash. This will get cancelled. So this I can write as 1 upon V minus 1 upon U. Here if I take mu minus 1 common, then inside I will get 1 upon R1. Can you tell what will come in the second term, plus or minus?
Minus.
Minus 1 upon R2 is 1 upon V minus 1 upon U. When object tends to infinity, where the image will tend to focus.
Focus.
So when object is at infinite distance, image will come to focus. And it is ulta also. When object is at focus, image is at infinity. So we can say mu minus 1 into 1 upon R1 minus 1 upon R2 is 1 upon F minus 1 upon infinity. What is 1 upon infinity? Is it 0?
Yes, sir.
Yes, sir.
So this will become 1 upon F minus 0 is mu minus 1 into 1 upon R1 minus 1 upon R2. So 1 upon F is mu minus 1 into 1 upon R1 minus 1 upon R2. This is known as lens maker's formula. This is known as lens maker's formula. One more line. Okay, please copy till this. 1 upon F is mu minus 1 into 1 upon R1 minus 1 upon R2. This is known as lens maker's formula.
Done, sir.
1 upon f equals to mu minus 1 into 1 upon r1 minus 1 upon r2 is known as Lensmaker's formula. From 3 and 4 we get 1 upon f is 1 upon v minus 1 upon u. So when v and u given, then use 1 upon f as 1 upon v minus 1 upon u for length. So just two more lines. Completed?
Yes, sir.
Case 1, double convex lens. For double convex lens, left hand side is every time first one and right hand side is taken second. Can you tell me what is R1 ka center, on the left or on the right by convention? Where is the center of this side? Right or left?
Right.
Right.
Right. And center of this other one?
Left.
Left. Right is taken as positive. So by sign convention, R1 is plus and R2 is minus. Therefore, 1 upon F, which is mu minus 1 into 1 upon R1 minus 1 upon R2 will become 1 upon F mu minus 1 1 upon R1 minus of 1 upon minus R2. So 1 upon F is mu minus 1 upon F into mu minus 1 upon R1 plus 1 upon R2. Now 1 upon R1 plus 1 upon R2 will be positive or negative? This 1 upon R1 plus 1 upon R2 will be positive or negative? So much time to think. R1, R2 plus plus will be plus only the answer.
Yes, sir.
And mu is greater than 1. What will be mu minus 1? Positive or negative?
Positive.
Positive. So we can say thus focal length of convex lens will be positive. So sometimes they can ask from Lensmaker formula, show that the convex lens focal length is positive, right? Case 1, double convex lens, and then proceed. Completed?
Yes, sir.
Okay. If it is double concave lens, then see how to. Case 2, double concave lens. This is double concave lens. Left side is R1, right side is R2. Here, what is R1? Plus or minus now?
Minus.
Minus. And R2 plus. So 1 upon F is mu minus 1, 1 upon R1 minus 1 upon R2. So it will become 1 upon F equals to mu minus 1, 1 upon minus R1 minus 1 upon R2. So 1 upon F will be, I'm taking minus outside, mu minus 1, 1 upon R1 plus 1 upon R2. Now this is positive and multiplied by negative. So therefore focal length of concave length will be negative. Clear na? Positive into negative. So plus into plus is plus, plus into minus is minus, therefore it will be negative. Right, for double concave lens, focal length negative. So convex we are getting positive, concave we are getting negative. Is completed?
Yes,
Done,
sir.
sir.
Okay. Right, heading optical instruments. Optical instruments. So if the object is not visible properly, then we use some instrument so that it can be enlarged. This object is seen large or small actually depends upon what angle it subtends on our eye. Suppose this is one object and my eye is very close to the object, then it will subtend this angle. Same object I take far. Now this will subtend smaller angle on my eye. If I take still far, still it will subtend smaller angle. So actually this is angle subtended by object which makes us feel that object is small or large even though its size remains same. So by using optical instrument, if some object is not visible from the far distance, then we have to magnify that. How it will get magnified? That depends upon a ratio called as magnifying power. The power of lens is ability of lens to converge the rays or diverge when it passes through it. It is reciprocal of focal length measured in meter. SI unit is diopter. Linear magnification is height of image to the height of object or ratio of distance of image to the distance of object. Now we are doing what is magnifying power. It is also called as angular magnification. So magnifying power or angular magnification term, both are same, don't get confused in the exam. So magnifying power, or it is also called as angular magnification. From the name it is clear, angular magnification, that means it is related to angle. Angular magnification. It is defined as the ratio of angle subtended by final image. Final image because compound microscope will have two images, one by objective, other by eyepiece. So we are talking about final image. Angle subtended by the final image denoted by beta at the center of lens. It is defined as the ratio of angle subtended by final image at the center of lens to the angle subtended by object when placed at distance of distinct vision. Distinct vision means distance of 25 centimeter to the angle subtended by object when placed at distance of distinct vision and seen directly, denoted by alpha. Therefore, magnifying power m dot p equals to beta upon alpha. So ratio of angle subtended by the final image at the center of lens to the angle subtended by the object when placed at distance of distinct vision and seen directly is called as magnifying power. So beta upon alpha is the formula. Write down. Hello? Hello? हाँ हेलो हाँ बोलो हाँ भेजा होगा ठीक है मैं देख के बताता हूँ अरे लेक्चर चालू है अभी आज जब आपको बोलते हैं तब आप बताते हो जब भेजते तभी नहीं मानता क्या संडे बना दिया होता मैं ठीक है देख के बताता हूँ ठीक है
Done, sir.
Done, sir.
So optical instrument, whenever they say find magnifying power, we have to find alpha and beta and take the ratio. So first instrument which we have to study is simple microscope or magnifying glass. In exam they can ask with proper ray diagram, derive expression for magnifying power of simple microscope. Simple microscope or magnifying glass. See, beta is angle subtended by the image and alpha is angle subtended by the object when placed at distance of distinct vision. So first I am taking this object, suppose AB, placed at distance of distinct vision D, seen directly. So angle subtended at the eye is alpha. So here we can say by sign convention, tan alpha is approximately alpha because angle is very small, is opposite side AB upon adjacent side D, negative because it is on the left hand side. So AB upon minus D by sign convention we are getting alpha. To get beta we have to draw ray diagram. So suppose this is a convex lens. Convex lens. This is f at distance of 3 centimeter. Here also you take f at 3 centimeter. Object can be adjusted by moving the lens. So we have adjusted in such a way that object is close to P to get magnified image on the same side and virtual. So to get its image, we have to draw ray parallel to principal axis first. It will pass through focus and passing through optical center remains undeviated. Optical center remains undeviated. If we produce both of them backwards, then it will meet at a point. Produce this backwards, even this backwards. It will meet at certain point. Call this as A1, B1. This is object distance U. This one is image distance V. Angle subtended at the center of lens is beta. And we are observing from this side. Draw the ray diagram. First you draw this AB, capital D, and below that draw this ray diagram for simple microscope. सचिन भी लेक्चर है, देख के फिर मैं बताता हूँ.
Done, sir.
So we got alpha. Now we'll see beta from that figure. Can you see beta is opposite side AB upon U?
Yes, sir.
It can be
Yes, sir.
also taken as A1 B1 upon B.
Yes, sir.
Okay. So after drawing ray diagram, we can say from the figure, from the above ray diagram, beta equals to AB upon U. AB is upward, U is on the left, so minus. It is A1 B1 upon minus B. Now magnifying power M dot P is beta upon alpha. So magnifying power is beta, which is AB upon minus U. Alpha, we got AB upon minus D. So AB we can cancel. Magnifying power is D upon U. So this is expression for magnifying power of simple microscope, D upon U.
Done, sir.
Okay. Right. Case 1. Case 1. If the object may be anywhere, image is supposed formed at distance of distinct vision. Case 1, image is at DDV, or it is also called as near point. So here U is anywhere on the left hand side and image is on the same side, that is left hand side, but at distance of distinct vision. Since 1 upon f is 1 upon v minus 1 upon u for length, so 1 upon minus d minus of 1 upon minus u minus 1 upon d plus 1 upon u. Therefore, d upon f will become minus of d upon d plus d upon u. So d upon f is minus 1 plus d upon u. So 1 plus d upon f is d upon u. D upon u means magnifying power will become 1 plus d upon f. D means 25 centimeter and f depends upon focal length of that lens. So if image is at DDV or at near point, then 1 plus d upon f is magnifying power. Right, case 1.
Done, sir.
Case 2. Image, yeah, 1 minute. Case 2, second case. Case 2, image is at infinity, or it is also called far point, or it is called relaxed eye position. दूर है तो आंख में कुछ स्ट्रेन नहीं आता है, उसको रिलैक्स्ड पोजीशन बोलते हैं. So now object is anywhere on left, image is at infinity. So 1 upon f is 1 upon v minus 1 upon u for length. That is 1 upon infinity minus of 1 upon u. So 1 upon f, 1 upon infinity is 0 plus 1 upon u. 1 upon f, 1 upon u. D upon f, d upon u. So magnifying power will be d upon f if image is at infinity or far point or relaxed eye position. Right. अभी ले ये आपका गाड़ी वगैरह शायद गाड़ी वगैरह शायद नहीं वो लोग वो डाल दिया करने का चलेगा तो बता देगा ना जगह नहीं पास करेगा तो ये भी चले पास करूंगा तो बॉल वॉल मारेगा अभी बॉडी बना दिया हाँ इसलिए तो बोल रहा हूँ ले लो जो बढ़ता है ना वो और बढ़ेगा पानी बढ़ गया तो रुक जाएगा 0 का 3 होने में टाइम लगता है 3 का 6 होने में टाइम लगता है 3 का 6 बढ़ जाता है बट बेच देना डेढ़ मेरा का भरोसा नहीं डेढ़ को बेच दो या एक इंट्राडे का ही लगेगा डेढ़ बेच दे अरे इतना रिस्क नहीं लेता सीएनएस बैंक बड़ौदा में इसमें क्या 10 पॉइंट का मूव मतलब फिर उठाया जाएगा एक देखना पड़ेगा पहले आईजीएल बता दो आईजीएल 3548 हो गया वो कॉल नहीं दिया था 75 कैश हो गया ठीक है फिर अच्छा प्रॉफिट हो गया निकाल दो जैसा ही तो एक दो बजे के बाद में बढ़ जाता है मैं भी डीएलएफ निकाल के हो जाता है डीएलएफ थोड़ा निकाल कितने का लेगा
Done, sir.
Okay. So simple microscope, we did ray diagram, definition of magnifying power. Magnifying power का formula D upon U for normal conditions, 1 plus df d by f when image is at ddv, and d upon f when image is at infinity. Now write compound microscope. Compound microscope. Again, first alpha. Alpha is nothing but angle subtended by object when placed at distance of distinct vision and seen directly. So by sign convention, we can get alpha equals to AB upon minus D equation 1. Ray diagram. So this I have drawn principal axis on which we have got objective. Convex lens has got two objects. One is objective, which is close to the object of smaller size, and second is eyepiece of larger focal length. So this is suppose focal length f0 at 1.5 on both sides you draw. Slightly beyond f0 we place object AB so that we get magnified real image on other side. So this is magnified real image on other side we'll get. Magnified image on other side we'll get. 1 minute. The ray after passing through the lens passes through focus and passing through optical center remains undeviated. So it intersects here. We get image A1B1, which is slightly magnified as compared to the object AB. Object distance is U0 and this image distance is V0 from object. Now, eyepiece can be adjusted in such a way that we get magnified virtual image on the same side of object. A1, B1 behaves as object for eyepiece. Eyepiece is like simple microscope. So we can bring it very close to the object A1, B1. Eyepiece we can adjust. So it can be brought closer so that this A1, B1 lies in between F and P of eyepiece. So this is suppose focal length of eyepiece. Ray drawn parallel to principal axis will pass through focus. Passing through optical center remains undeviated. Produce it backward. Wherever it meets, that becomes my final image A2, B2. Distance is VE. Angle subtended is beta at the center of lens. So this is ray diagram for compound microscope. Draw it properly, then I am explaining how to get beta and upon alpha relation. हेलो, अब फिर बजाज फाइनेंस का कॉल लेना था 5000 का, तो ये आईजीएल निकाल के आ सकता है? 5000 कितना जा रहा है? अच्छा, बड़ा है क्या उसका मार्जिन? 5000 का कॉल? नहीं नहीं, बैंक ऑफ बड़ौदा का नहीं बोल रहा था मैं, आईजीएल का बोल रहा था। आईजीएल निकल के, हाँ हाँ हाँ, 5000। अच्छा, दो 250 का है ना बात? तो आ जाएगा क्या वो निकाल के? अच्छा अच्छा, फिर से निकाल के वो देखो ना। हाँ करो करो, ठीक है निकाल। 5 शायद होगा लगता है। नहीं नहीं पकड़ेगा ना? हाँ, तो अभी 40 है, तो अभी नया नहीं लेगा क्या? अच्छा हाँ, अच्छा तो ट्रांसफर करो क्या अभी? लेकिन तब तक पहुंचेगा नहीं ना, टाइम लगे। अच्छा अच्छा, ऐसा रहता है, ओके ओके। हाँ, तो फिर रुकना पड़ेगा ना? बराबर है। कितने का कम पड़ रहा है बोलो? अपना इन्फोसिस कितना है कम है? तो अपना 1350 में है ना शायद, अगर अपन 25 निकालेंगे तो हो जाएगा। 25 में 20 निकालेंगे तो भी हो जाएगा। जान दो, जान छोड़ो छोड़ो, मतलब नहीं, जान दो जान दो। ठीक है ठीक है। यस कंप्लीटेड।
Yes, sir.
Sir,
हाँ हाँ,
I am trying. I am not getting with the second lens.
take focus at large distance FP, then you will get perfect. See, not necessarily you will get same as what I have got. You can get A2 B2 anywhere.
I'm getting behind the second
No
lens.
problem, that is okay, no
Full,
problem.
on the full right.
हाँ, no problem, because F2 is adjustable na FP. So as per that, A2 B2 will keep on changing the position. So even if you are getting on objective, no problem. More FP long away you take, more better you will get the diagram. Everybody has done full?
Yes, sir.
Yes, sir.
Shall I clear now? We got alpha, we can see beta also from the figure. So I will just show how to get beta upon alpha for compound microscope. From the above ray diagram, beta is equals to opposite side. What you can see opposite side? A1 B1. Can you see
Yes,
A1
sir.
A1 B1? It is on left side. A1 B1 is down or up? A1 B1, this image is down or left? Upward?
Downwards.
Downward.
Downward means negative. And opposite side A1 B1 upon adjacent side UE, correct?
Yes, sir.
UE. On the left, therefore this is also negative. Or can I say it is A2 B2 upon VE?
Yes, sir.
Yes, sir.
Okay, minus 10. Therefore, magnifying power m dot p is beta upon alpha, that is equals to beta is A1 B1 upon UE and AB upon minus D. We can see this is AB upon minus D alpha. So from above ray diagram, beta equals to A1 B1 upon UE, which is same as A2 V2 upon VE, but I selected first because we will get some relations. So this will become A1 B1 upon UE minus D upon AB. That is minus A1 B1 upon AB into D upon UE. Negative sign indicates that final image is inverted with respect to object. Is inverted with respect to object. Okay, please copy till this. Then one more line we have to explain. Yes, done full.
Yes, sir.
Yes, sir.
final image is inverted with respect to the object. A1 B1 upon AB equals to MO, which is linear magnification of objective, and D upon UE is ME, that is magnifying power of eyepiece. Therefore, magnifying power of compound microscope M dot P equals to linear magnification of objective into magnifying power of eyepiece. Copy these 3 lines now.
Done, sir.
Again, there are 2 cases. Case 1. Image is at DDB. Therefore, magnifying power, which is M naught into ME, can be written as V naught upon U naught. Linear magnification we can also write as image distance, distance of image upon distance of object. 1 plus D upon F. Case 2. Image is at infinity. So magnifying power is MO into ME, that is equals to V naught upon U naught D upon FE. Write these two cases.
Done, sir.
We are using now compound magnifying power of astronomical telescope. Astronomical telescope. Here magnifying power will not be for object situated at DDV because object is at very far distance. So first we'll see ray diagram. In this astronomical telescope, objects are very far, therefore size of objective is very large so that it can collect large number of large beam of light or intense beam of light. Astronomical telescope objective is large as compared to eyepiece. So this is objective. Object is at far distance, so it will be sending the parallel rays which makes small angle with the principal axis. These rays after passing through lens converge at a point which lies in the focal plane. is converging at a point which lies in the focal plane of eyepiece. So this is object, which is very small because when object is at infinity, then its size is dot. So object is at infinity. This is angle alpha subtended by the object at the center of lens. So we can call this as A1, B1. This is in the focal plane because infinity, then image is formed at focus. So this is focus of objective. Now eyepiece is adjusted in such a way that the object lies at focus of the eyepiece, so that image also goes to infinity. That means we see the enlarged object but not very close, it is at very far distance. So whatever distance we have taken A1 to P, same will be for this focus on the other side. When ray is parallel to principal axis, then it will pass through focus. Passing through optical center remains undeviated. So it will be almost parallel beam of light, remaining undeviated. So this is that ray of light. Produce them backward, it will be parallel. So the image is also at infinity. This angle is beta. So we can say from the ray diagram, magnifying power equals to beta upon alpha. Alpha is opposite side A1 B1 upon adjacent side FO. Object is below, therefore minus alpha. Beta upon alpha. So first we'll get beta. First draw the ray diagram. Draw ray diagram properly. Ray diagram done?
Done, sir.
Okay, then write from the ray diagram, magnifying power beta upon alpha is A1 B1 upon Fp, A1 B1 on downward, so negative, Fp left negative. And then for alpha, A1 B1 downward negative and F4 right, therefore positive. Ray diagram, can I clear for everybody?
Yes, sir.
Beta upon alpha write properly. So this A1 B1 cancel, magnifying power is minus F4 upon Fe. Again negative sign indicates that final image is inverted. That is, this is in magnitude F4 upon Fe. Length of telescope equals to distance between objective and eyepiece is called as length of telescope. So can you see the diagram and tell me what is distance between objective and eyepiece? Distance between objective and eyepiece, can you see clearly?
Infinity.
No, F4 plus Fe है ना? ये objective, ये eyepiece, ये F4, ये Fe, ये है ना distance.
Yes, sir.
So it is F4 plus Fe's length of telescope, because they will have favorite sum. Distance between telescope will be given or this ratio will be given. Find F4 Fe आ जाएगा. Length of telescope is F4 plus Fe. Can I clear this now?
Yes, sir.
Yes, sir.
Compound microscope का भी length देख लेते हैं note में. Length of compound microscope. Length of compound microscope L equals to. Now if you see compound microscope from the ray diagram in your book, this was object at image as V naught और दूसरे वाले का इधर VE था, UE था, है क्या बराबर? देखो ऐसे ही है.
Yes, sir.
So it is V naught plus UE. But if final image is at infinity, then QE should be focused, then only the image will be at infinity. So
Yes,
L will
sir.
become V naught plus Fe. Right, these two formulas. Done?
Yes, sir.
One very small numerical we are writing. Right, first one. Find the refractive index of prism if angle of prism is equal to angle of minimum deviation. Find refractive index if. So refractive index means mu we have to find, and angle of prism is equal to angle of minimum deviation given by prism formula. Refractive index is sine of a plus delta m upon 2 divided by sine a by 2. That is nothing but sine of delta m and a are same. So we can say a plus a upon 2 divided by sine a upon 2. So mu equals to, what is sine a plus a?
2a.
2a
2a divided by 2, what you will get? Sine a
A.
sine a.
upon sine a by 2. In maths you have studied, what is sine 2a formula?
Yes,
2
sir.
sin A cos A.
Very good. So 2 sine a by 2 cos a by 2 divided by sine a by 2. So a by 2, sine a by 2 cancel. So mu becomes 2 times cos a by 2. Don't cancel 2 to 1. Just this is the answer. Mu equals to 2 times cos a by 2. Right.
Done, sir.
So that's all for today. Next we'll meet on Thursday again. Same topic continued.